At the southern hemisphere, you will find that when you are standing this way, you will be looking, everything will be revolving around that center, which is the south celestial pole. But sadly, there is not uh, a star as bright as Polaris, so it cannot guide them the same way. So as you move away uh, from the equator, this star Polaris in the northern hemisphere, it can tell you your direction towards the north and your latitude also. This angle can tell you your latitude. Okay, we assume that stars are all attached to the celestial sphere, and that's for ease in calculations, to make it easier, because it's almost the same distances, because they are very far, so in their movement they appear as if they are at the same distance. So we use the 360 degrees in circle, and this has 60 arc minutes in a degree, 60 arc seconds in an arc minute. So the sun is half a degree, and so is the moon, and that's why they have solar eclipses, because they appear the same size due to the different distances and different sizes. Okay, so if this was the over the sky over the horizon, this will be the moon, just half a degree. So this is Polaris. Everything appears to be revolving around it, because the Earth is revolving around itself, and once a day, and this movement causes everything to appear revolving around the center, which is Polaris, because it's at the top of the Earth axis. And as you move near to the horizon, you will see Polaris next to it. This is the same thing. This is away from the horizon. So we have two hypotheses. One, which was by Ptolemy at 2nd century, which is Earth is stationary. Stars are attached to a sphere that revolves around the Earth once per day. This is wrong. But we assume that stars are stationary and Earth rotates about its axis once per day, and that's the right hypothesis in that was made by Copernicus in 16th century AD. Okay, that's the same thing we have been talking about, the position of Polaris relative to your position on Earth. This is, for example, near the Earth, and this is away near the equator, and this is away from the equator. Okay, the surface of the Earth does not have the same velocity over each part of it, and that's because it has to rotate all at the same time to be as a one body, and that causes the equator to be revolving much faster than the poles, which causes the Earth to be not a pure sphere but more of an egg or an oval body. And the same thing applies to all celestial bodies, all planets, all stars, everything. That's why there is nothing spherical ever in the universe. I mean pure sphere. So today's sun is in cigarettes, next month is in Copernicus, in Capricornus. Sun's path on the celestial sphere equals the ecliptic, and I showed you what's the ecliptic, and constellations through which the ecliptic runs the zodiac. The ecliptic is not the same as the celestial equator. It's it has an angle with it. I'll show you this. Okay, so if this was the equator, this is the ecliptic. This is the path of the sun during the year. Of course, this is apparent. The earth is the one moving, not the sun. It's the earth who is moving, and this intersection between the equator and the ecliptic is called the vernal equinox. And this annual motion caused that caused sun movement from west to east relative to stars about 1 degree per day is caused due to the earth movement around the sun. That's why there was a hypothesis by Ptolemy that sun revolves around earth at a slightly slower rate than the celestial sphere. But in the hypothesis by Copernicus, it says that earth revolves around the sun once per day per year. And this is how this happens. The earth moves and around the sun, and you can see it with different backgrounds all over the year. There are always different backgrounds. Like this one, it will be here in Scorpius, but here it will be in Leo. The same for the moon, but it's only 1 month cycle.